21. In the figure above, Q is the midpoint of PR. If PQ equals x plus 3 and QR equals 2x minus 1, what is the length of segment PR? Is it 4, 7, 11, or 14? What do you think? So since Q is a midpoint here, then it follows that PQ and RQ are equal with one another. So we have to equate these two, and subtracting both sides by x and adding both sides by 1 gives you x equals 4. And since x is 4, this means that PQ and of course QR is, by substitution to this one, you could have 4 plus 3 or 7 units long. In fact, the 4 plus 3 here is this x plus 3. That's your PQ. And if you wish, if you substitute it to QR, that is 2 times 4. That's 8 minus 1. It's still 7. So PQ and QR are both 7. And by the segment addition postulate, then it is simply 2 times 7 or 7 plus 7, which is 14 units long. So PR is 14 units. Letter D. 22. So take a look at these two lines. So they intersect. And this angle's here, 5x minus 12. And this one is x degrees. And this one is 3y minus 8 degrees. What is the value of y? Is it 32, 42, 52, or 62? It is noteworthy to see from this given that since this is a line or a straight line, then it follows that x and 5x minus 12 are actually forming a linear pair because they are adjacent, while at the same time, they add up to 180. So you have your x plus 5x minus 12. The sum of these two should be 180. So for now, I omitted the degree sign. And x plus 5x is 6x. Then this minus 12 on the left becomes plus 12 on the right. That's why 180 plus 12, it's 192. Dividing both sides by 6, you have x, which is equal to 32. So if x is 32, you could actually see that if you add x, this is a straight line. This also follows that x and this 3y minus 8 are also linear pairs because they are adjacent angles since they have this common. Of course, they add up to 180. And with that, if I add x and 3y minus 8, their sum should be 180 as well. But we know here that x is 32. That's why by substitution, you have 3y minus 8 plus 32, which is equal to 180 degrees. And subtracting both sides by 32 and adding both sides by 8, this isolates the term with the y. So we have 3y equals 156. Dividing both sides by 3 gives us y equals 52. So therefore, the value of y here is 52 and x has to be 32. I hope you got it. 23. So by the way, that's letter C. 23. In the figure, lines L and M are parallel. What is x? Did you go for 35, 40, 45, or 50? So for this one, let's have the following. So if you have this, take note, these two are parallel, and this segment here, in fact, serves as a transversal. And since this is acting like as a transversal, then this angle here and this acute angle here are in fact alternate interior angles. That's why this should also measure 55 degrees, because alternate interior angles are congruent, provided that L and M here are parallel. And what's next? You could also see that this one here is a right triangle. It's a triangle that is actually right because of this one. This is a 90-degree angle. And if you add all the measures of the three angles of a triangle on a plane, then their sum should be 180 degrees. But for now, I omitted the degree symbol. So 55 plus 90 is 145. And I have here x plus 145 equals 180. Subtracting both sides by 145 gives the value of x, which is 35. Letter A. I hope you got it as well. Next number, 24. In the figure, BC is parallel to DE. So this one here, parallel. And AB is parallel to CD. So given these measures here, this is the acute angle here, this is 65. What should be the measure of x? Is it 118, 120, 135, or 144? If you could see from the figure, this has to be 65 degrees. Why is that so? Because these two are parallel, and these two are corresponding angles. That's why this should be 65 degrees as well. And aside from that, remember this angle here, if you add 65, 68, and this angle DCE, remember they're forming here a 180-degree angle, because this is like a semicircle here. And with that, subtracting 65 plus 68, the sum of these two angles from 180, you actually get a value of 47 degrees. So therefore, this angle DCE is in fact 47. However, since these two lines here or segments are parallel, then this follows that x here and 47 are also corresponding angles. And remember, corresponding angles of made by that are formed by a transversal that passes through two parallel lines at two different points are actually congruent. Hence, this x here should be 47 degrees. But since 47 is not one of the choices, then the correct answer here is E. I hope you got it. 25. In the figure, QP is parallel to ST. What is the angle measure of QRS? Is it 95, 100, 105, 110? Pause the video if you wish and try solving on your own. All right. Now, if you could see from here, there are actually many ways of doing this. Others are extending this segment here and extending this segment also here. They form a triangle and so on. But actually, my technique or the way that I will solve this will be quite different. To solve for this one, I will actually connect P and T. Note, or if you wish, I could connect it here as well. I could draw a vertical line here. And since QP and ST are parallel with one another, and if you draw a segment that is perpendicular to one of them, then it is also perpendicular to the other segment. That's why even if I draw here, it will still be 90, 90. And if you could notice, you could actually see that this is in fact a pentagon. And remember that the sum of the interior angles in degrees of a convex pentagon, either regular or irregular, I hope you could still remember the formula, 180 times n minus 2. So in this case, it's S equals 180 times number of sides, which is 5 minus 2, which is 540 degrees in all. So if I add all of these interior angles here, I'm sure it's 540 degrees. But the four angles are given, which is 110, 145, 90, 90. And there's one angle left. And hence, therefore, angle QRS could be taken or could be solved by subtracting the sum of these four interior angles from the total sum, which is 540, giving us 105 degrees, which is the measure of the remaining angle. If you go for C, great job. You got it right. All right. Number 26. In the figure in triangle ABC above, if AB equals AD equals DC, what is the value of X in degrees? Did you go for 108, 102, 98, or 92? Okay, so let's solve this problem. So remember that based on the given that these three segments are in fact equal. And this tells us that ADC is in fact an isosceles triangle, right? And in an isosceles triangle, the sides opposite the legs, or what we call base angles, are also equal. So if this is 18, this is another base angle, so it has to be 18 as well. Also, we know that ADC here is a triangle, and the sum of the measures of the interior angles of a triangle is 180. That's why to get the measure of angle ADC, I have 180 degrees and subtract it with these 218 degrees. That's why angle ADC is 144 degrees as shown here. Next one, we could actually see that angle BDA here and angle ADC are in fact forming a linear pair. And since they are a linear pair, they form a linear pair, they should be supplementary. Hence, to get the angle ADB, this one, subtract 144 from 180, and this should be 36 degrees here. All right. Moving on, remember this triangle ADB, this triangle, is still isosceles. Why? Because of this two tick marks, that AB and AD are congruent. So this means that this is another base angle, which is equal to 36 as well. And lastly, this angle BAD, or which is X, this is, remember, BAD is a triangle, and that the sum of all the measures of the interior angles is 180. That's why 180 subtracted by these two 36s gives you 108 degrees. That should be 108 there. So if you answered letter A, great job. 27. In the figure, the area of right triangle ABC is 60. What is the perimeter of triangle ABC? Did you go for 34, 36, 38, or 40? What do you think? From this one, you could actually see that the area is given, and we know that area equals 1/2 base times height. So this CB here could serve as the base, and this AC could serve as the height. We're given the area to be 60, so that 60 equals 1/2 times 15 times the height of this AC, which I represent with H. And multiplying both sides by 2, you will get 120 equals 15H. But dividing both sides by 15, we get the value of the height, which is 8. I believe you would agree with me that the height there is indeed 8. Because if you could see 8 times 15 divided by 2, so your height here is 8. And we are looking for the perimeter, and we still need to get the value of AB. But you could see that this is a right triangle here, so the Pythagorean Theorem is applicable. Let's call the length of AB as x. And by the Pythagorean Theorem, the square of the hypotenuse is equal to the sum of the squares of the two legs. So x squared equals 8 squared plus 15 squared. 8 squared plus is 64. 15 squared is 225. And they have a sum of 289. So x squared is 289. Getting only the positive value or the principal square root, because there's no such thing as a negative length. Therefore, x here is 17. So that should be 17 there. And since we have now the values of all of the three sides, then we can now determine the perimeter, which is simply the sum of all the measures of all the three sides. Hence, perimeter equals 8 plus 15 plus 17. That gives you 40 units. Letter D. I hope you got it. Number 28. So take a look at this figure here. A person 6 feet tall stands so that the ends of his shadow and the shadow of the pole coincide. The length of the person's shadow was measured 7.5 feet, and the length of the pole's shadow, SD, was measured 18 feet. How tall is the pole? So refer to this illustration here. So this is the man, and this is the pole. Here's the 7.5 shadow of the man, and here's the 18-foot shadow of the pole. Note, it's important to note that the person and the lamp here, or the pole here, are both vertical. So these are in fact understood to be right angles most likely. So let's say we don't know the length of that. Let's call it x. And since these two are both vertical with these are in fact, we have two similar triangles. By proportionality, we have 6 over 7.5. So it's the one vertical over the horizontal equals the same thing, vertical x over the horizontal, which is 18. And employing some sort of cross multiplication or multiplication property of equality, 7.5 times x is 7.5x. 6 times 18 is 108. Dividing both sides by 7.5 gives x as 14.4 feet. Letter C. If your process is different from mine, no worries. What's important is we get the same correct answer using sound principles. 29. In the figure, if PS here is equal to 162, what is the length of segment QR of this segment? Is it 42, 45, 48, or 51? From the figure here, you could actually see that you have this one, PW, QV, RU, and ST. They are all forming a right angle with respect to this horizontal one. So this implies that they are all vertical, assuming that WT is horizontal. And that since they form right angles here, this implies that PW, QV, RU, and ST are all parallel with one another. And if they are parallel, and if these are the ratios of the lengths of WV, VU, and UT, then it follows that this is also 3x, 2.5x, and 3.5x as well. That's by virtue of proportionality. With that, since PS is 162, so this is 3x plus 2.5x plus 3.5x equals 162. You get 9x equals 162. Dividing both sides by 9 gives x equals 18. And you have your 18, so what's next? QR is also 2.5 here, right? And since x is 18, so 2.5 times 18 here, that gives you 45 as the length, letter B. 30. Find the area of parallelogram PQRS as shown. So take a look. Is it 120 square root of 3, 90 square root of 3, 80 square root of 3, or 60 square root of 3? What do you think? For this one, you could see that this is a 60-degree angle, and this is a right triangle here. So PQT is a right triangle as well, because if this is 90, this should be 90 as well. And if this is 60, then the PQT, angle PQT has to be 30. So triangle PQT is a 30, 60, 90 right triangle. And remember that in a 30, 60, 90 right triangle, so PQ here serves as the hypotenuse, since, or PQ is the hypotenuse, since this is a right angle, PTQ is a right angle, and the hypotenuse is opposite of your right angle. The side opposite the 30-degree angle is half of your hypotenuse. That's why this is the side opposite of 30 degrees, so this is half of 10 or 5. And the side opposite the 60-degree angle is square root of 3 times the shorter leg, or the side opposite, or square root of 3 times the side opposite of the 30-degree angle. So 5 times square root of 3, that's 5 square root of 3 here. And we know that the area of a parallelogram could be determined by base times height. So if this is 12, it's also known that PS is 12 because opposite sides of a parallelogram are congruent. So your base here is 12. Your height here is 5 square root of 3. And that's 12 times 5 square root of 3, or 60 square root of 3 as the area. D is the correct answer. Okay,